Hello students, today we'll cover the second part of acid, base and salt, chapter 2, class 10 science, chemistry. Let's start. What is base? We already have the idea that the solution or the substance that tastes bitter and feel soapy on touch are bases. Today we'll learn a bit more about the base. Now, what is the new definition of base? The new definition says that solution that has an excess of OH minus ion. The other name of OH minus ion is hydroxyl ion. So the solution that can produce or have excess of OH minus ion are called bases. There is one more definition of base that says that the substance that can accept H plus ion, that is also termed as base. So 90% of the definition of base goes for the one that furnish excess of OH minus ion, and without OH minus ion also we consider some bases that can accept H plus ion. Now we'll see two examples regarding that first 2 point. In first one you see sodium hydroxide is the base. Okay, so sodium hydroxide will provide OH minus ion, and you know that acid is what? Acid is a substance that furnish H plus ion. So sodium hydroxide will provide OH minus ion. Acid will provide H plus ion. So H plus and OH minus ion will combine to produce the water, and the remaining part will combine together to form the salt NaCl. This is an acid-base reaction. It is called neutralization reaction. We'll learn it later in detail. In the second reaction you see HCl, again the acid is being treated with ammonia, but here what ammonia is doing, NH3 ammonia is accepting the H plus ion, forming NH4 plus, and the counterpart Cl minus also being added here. So in the second case ammonia do not have any OH minus ion, but still it is base because it is accepting one proton. And in the first one, sodium hydroxide, it is accepting the proton as well as it is able to furnish OH minus ion in the solution. So we can say that the base is the solution that can give OH minus ion or can accept H plus ion. The taste of base is bitter, and when we touch the basic solution it will soapy. We have already seen some example of bases. The detergent, the soap, the bleach, the chalk, these are some example of common bases. Some more common bases are given here. We have to remember some of the names. Aluminium hydroxide. See, it have OH minus ion. In the formula you are getting the OH minus, so it's a base. What is the use? It is used as antacid and in deodorant. Then is your ammonium hydroxide, NH4OH. It is also a base furnishing OH minus ion. It's a glass cleaner. Calcium hydroxide, it is termed as caustic lime. The formula is CaOH2. Then magnesium hydroxide, MgOH2. It is laxative, or you can say it is an antacid. The common name of magnesium hydroxide is what? It's a milk of magnesia. Sodium bicarbonate or sodium hydrogen carbonate, the same thing. Instead of hydrogen, the word bi is being used here. The formula is NaHCO3. The common name is baking soda. Then sodium carbonate, dish detergent, Na2CO3. In this case you see it's a salt, okay, but it's a basic in nature. Okay, we don't have any OH minus ion. Rarely it will accept the H plus ion too, but why we have considered it as base? Because it is a basic salt. Sodium hydroxide, it have OH minus ion. Then sodium hypochlorite, NaClO, it is used as a bleach for cleaning the cloths and all. We use it. So these are some common bases. Next we'll see the type of base. Now we can classify the base as per their strength, as per their concentration. Now let's see how we can classify the base as per the strength. So two type of base we get. One is strong base, another is weak base. Strong base are those bases which completely dissociate it to its ion in aqueous solution. Remember the word completely dissociate. Okay, sodium hydroxide, if you give in water, aqueous means water. Sodium hydroxide, when you given in water, they will break down to form Na plus and OH minus ion 100%. Same as potassium hydroxide. So if they dissociate, they are able to produce lot of OH minus ion. And if the concentration of OH minus ion is more, we have to term the base as a strong base. Next is weak base. So what is the case of weak base? Weak bases are those bases which do not completely dissociate into its ion in aqueous solution. So weak bases will not completely dissociate, but partially they will dissociate. That means if you are giving a weak base in the water, they will hardly produce OH minus ion. So concentration of OH minus ion will be less, and hence the base will be a weak base. What is the example? Example is sodium hydroxide. So strong base are what? Sodium hydroxide and potassium hydroxide. Weak base example is ammonium hydroxide. Okay. Next, classification of base based on the concentration. If you remember, based on concentration, we got two type of acid, dilute acid and concentrated acid. Same the case in base. So here also we get two type, dilute base and concentrated base. Now dilute base is what? They have a low concentration of alkali in the solution. The term alkali must be new to you. I'll explain it. Then concentrated base have high concentration of alkali in aqueous solution. Now alkali, what is the meaning of the term alkali? Alkali is nothing but the water soluble bases. Okay, alkali is what? It is the water soluble bases. That means some of the bases get easily dissolved in water. Those bases are called alkali. So here you have to remember one thing, that all the alkalis are bases, but it is not necessary that all the bases are alkali. Only the part of the base, only those bases which are water soluble are termed as alkali. Okay, now when we are discussing the concentration, we are discussing the concentration in aqueous solution, right? So we have to deal here with the alkali. So dilute bases are what? These are the bases that have lower concentration of water solubility in water solubility in their solution, in their aqueous solution. Now we have completed the acid, we have completed the base concept, we understood what is acid, what is base. Now we'll see what is the salt actually is. Okay, now what is salt? Salts are ionic compound. Salts are what? These are ionic compound. Ionic compound means what? They're composed of ions that result from neutralization reaction of acid and a base. They are composed of cations and anions. As I told you, ionic compound contains ion. So what are the ion present here? Cation, and the counterpart is anion, so that the product is electrically neutral. If you're having cation and anion both in the compound, that means positive charge and negative charge both, the plus minus will neutralize each other and the overall value will become 0, and hence it is being called electrically neutral. So salt are what? Salt are the ionic compound that are formed from acid base neutralization reaction. In salt we get one cationic part and one anionic part. And what is the overall charge on salt? 0. Okay, they are electrically neutral. There is no charge on salt. Now let's understand what is neutralization reaction. Neutralization reaction is basically the reaction between the acid and that of base. So if you mixed acid and base, always it result in salt plus water. Okay, so acid, base, if you mixed, what will be the result? The result is always salt and water. One example is being given here. HCl is, HCl is an acid. Sodium hydroxide is a base. So acid plus base, if you're mixing, then it is a neutralization reaction. What is the product of neutralization reaction? Necessarily, it must be a salt and water. The formula of water is H2O. Now, how H2O is being formed? Acid will donate H plus ion, base will donate OH minus ion, H plus and OH minus ion will combine to form water. What is the remaining part? Na plus and Cl minus. So this Na plus and Cl minus, Na plus cation and Cl minus anion will combine to form the salt, right? So neutralization reaction is basically the reaction between acid and base that result in the formation of salt and water. This part you have to remember, right? So hope the salt part is clear to you. Now let's see some common salt. Now when I say the term common salt, you might be thinking about your table salt, right? What is the color? The color is white. What is the formula of the table salt you eat in your food? Sodium chloride. That is the common salt. Now, do you think that all the salts are white in color? Not necessarily. Salt does not mean that it will have the same chemical formula and the same color. Salt is what we understood. Salt is the compound having two parts, cation and anion. And not necessarily that all the salts are white. The salts are available in a variety of color. Let's see that. Now here you see in test tube different salts are kept. Okay, let's introduce the different salt. This yellow salt is the sodium chromate. Okay, next this blue color salt is very common, you know, this is the copper sulfate. The orange one is the potassium dichromate. That green one is nickel chloride. This purple one is the potassium permanganate. So in this compound you are getting two part, one cationic part, one anionic part. So all of these are salt. And one more thing we noticed here, that different salts are available in different color. One list is given regarding the different color of different salt. Next, let's see this numeral. The question is given as, how is concentration of hydroxide ions OH minus affected when excess base is dissolved in a solution of sodium hydroxide? Okay, so sodium hydroxide is a base because it furnish OH minus ion. Now they have said that if you're adding some more OH minus ion in the solution of sodium hydroxide, then how the concentration will get affected. So excess base dissolved in a solution of sodium hydroxide will release more hydroxide ion. Therefore, the concentration of hydroxide ions OH minus will increase, and as a result, the overall basicity of the solution will reach maximum value. Next topic, we'll see the acid-base indicators. Now we know about acid, we know about base, also we got the idea about salt. Okay, but how to identify a given solution, whether it is an acidic solution or it is a basic solution? So you know, with the help of indicator you can determine what the given solution is basically what nature. Okay, so indicators of what? These are the substances that help us to identify a given solution as acid or as base. Now, one chart is given. We'll understand this chart. So here we have got three categories: natural indicator, synthetic indicator, and olfactory indicator. Natural indicators are what? These are the substances that identify acid and base, and we extract it from nature. That means these are either the microorganic product or the plant product. Okay, for example, litmus, red cabbage leaf, then flower of hydrangea plant, uh, then turmeric. Okay, these are some natural indicator. So what is the color change? In acidic solution, litmus show red color, and in basic solution the color changes to blue. Red cabbage extract, red color in acidic solution, green in base. Flower of hydrangea plant, blue in acidic solution, pink in base. Then turmeric, no change in acidic solution, but it become red in basic solution. Okay, so here are some natural color indicator. Why color indicator? Because they change color in acidic or in basic medium. So what about turmeric? In acidic medium, no change. In basic medium, it will become red. So if you give a drop of base in the turmeric, the color will become red, right? What about cabbage? It will exhibit red cabbage, exhibit red color in acidic medium, green in basic. And if it is in neutral, it will show that blue color. Okay, what about litmus? Lemon is acid, so litmus will show red color. Baking soda is a base, so red litmus will become blue. Now China rose, some colored flower petals also change the color. So what about China rose? They will show blue color in acidic medium and pink color in basic medium. Next is your chemical synthetic color indicator. So what are the chemically or synthetic color indicator? The name you have to remember, one is phenolphthalein, it's available in your lab. Then another one is methyl orange. So what about phenolphthalein? Phenolphthalein is a colorless solution. Okay, in acid it will show no color. Okay, it will not exhibit any color in the acidic medium, but as soon as you give the phenolphthalein in basic medium, it will become pink in color. It will exhibit pink color in the base. So phenolphthalein is colorless in acidic medium and pink in the basic medium. Now what about methyl orange? Methyl orange is an orange solution. In acid it exhibit pink color, and in base it exhibit yellow color. Okay, alkali means what? Alkali is the water soluble base. So if you are giving this methyl orange in the aqueous solution of base, that means in the alkali it will show yellow color, and in acid orange color will become pink. Next is your olfactory indicator. Now what is olfactory indicator? Olfactory indicators are the substance or the indicator that do not deal with the color, but they change their smell to identify the acidic and basic solution. Okay, so what are the example? Onion. Now what about onion? Onion retain its smell in the acidic medium, but the smell changes, the smell diminish if you add base over it, or if you add the onion in the basic solution, the smell will go. Okay, now about vanilla. Vanilla retain the smell in acidic medium, but in base they change their smell. Okay, so see the table, see the chart here. Olfactory indicator, what about onion? Characteristic smell retain in acidic medium, in base the smell goes. Vanilla essence, they retain the smell in acidic medium, but the smell goes in basic medium. Now there is one more olfactory indicator, that is clove oil. They retain the smell in acidic medium but lose the smell in basic medium. So these are your indicator. So first two, natural, synthetic, we have discussed about color indicator. One is from the natural origin, another is from the chemical origin. And olfactory indicator, they do not deal with the color but they deal with the smell. They changes the smell in acidic or in basic medium. Thank you. That much for today. Hope you understood.